Okay, so this is the drained condition when water can come out from the soil pores, and when that cannot happen, then that is called undrained condition. That means when for any reason water cannot come out from the soil sample after application of external pressure, squeezing any sponge kind of thing, if the sponge is wet, if we are squeezing the sponge, water will come out. Similarly, in the pores of soil, water is there, you are squeezing the soil, water is coming out. That is the drain condition. If that is not happening after squeezing, after giving external pressure, water cannot come out from the soil pores. That is called undrained condition. Now, this is the technical or theoretical definition of drained and undrained condition. But why these kind of conditions are appearing?
Changing volume.
No. This is not regarding related to this pipe foundation or the advanced soil mechanics. This is basics of soil mechanics. That is, if the soil particles are granular or cohesive, larger particles, then pore size is larger. We have studied in the soil mechanics, basics of soil mechanics. Larger particle means larger pores also. In the sand, larger particles, larger pores. That means in that kind of sandy soil, drainage may happen, drain condition may occur. But in clay soil, smaller particles, smaller pores. Sometimes in the clay soil, at a depth of soil strata, due to the application of overburden pressure and the smallest pores in the soil, in the clay soil, drainage of water cannot possible. And in that case, how huge amount of overburden pressure is acting on this? Drainage cannot be possible. That is the undrained condition. And undrained condition where I have given here the undrained shear strength, that is due to, we are considering here the clay soil or cohesive soil. Is that clear to all of you? Undrained and drained, because in the triaxial test, I think soil mechanics laboratory, in this semester or in the previous semester?
Yes.
Previous semester, triaxial test. Maybe some of you will perform triaxial test in your project works also. Okay, in that drained condition, undrained condition is there. To avail the practical condition, the field condition of soil. Undrained means the draining of water coming out through the pipeline that will open. That will be open. And if that pipeline is closed, then draining is stopped, and that is the undrained condition. Okay. So in this case, as we are considering here the clay soil or cohesive soil, the undrained shear strength is given. Now, if the cohesive soil is there, so what will be the equation or formula for shear strength?
Tau is equal to C.
Tau is equal to C. Tau means A is equal to C. Shear strength is equal to only C, because sigma tan phi is 0 for cohesive soil. So sigma tan phi will be 0. So only shear strength is equal to C, and that shear strength is for cohesive soil. That means in under undrained condition, cohesive soil means the undrained condition, no? Getting it, na? So this undrained shear strength is nothing but the C. Okay, if undrained condition is given and that is for cohesive soil, then that undrained shear strength is nothing but C is equal to shear strength. Is that okay? So that's why undrained shear strength I have given. Don't be confused. This is the C, because in the equation to determine the load bearing capacity, the first part QB, that is the point load bearing capacity, there will be only two parameters, C and NC. I can show you the equations. This part, this QB, this QB or this QB, only two parameters, only C and NC. So you need C, no? So C is given as the unbent shear strength. Unbent shear strength is given to confuse you. That unbent shear strength is nothing but this C. Why? That is clear now to all of you? No problem, I think. So in the examination, chemistry exam, obviously unbent shear strength will be given if that kind of cohesive kind of soil is given in your question paper. Okay, so don't be confused. If unbent shear strength is given for cohesive kind of soil, then that is nothing but the C or the cohesion, unit cohesion of the shear strength parameters. Okay. So this C is given here, that value is given. Okay, that value is given, but in a changing way. That is given as increased linearly from a value of 70 kN per meter square at a depth of 2 meter depth. That means from here 70 kN per meter square and 210 km per meter square at a depth of 20 meter. That means at 20 now, this is 20, here 210 kilonewton per meter square. That means the value of C is changing at a top to bottom of the pipe. This is the characteristics of soil. Maybe different kinds of soil should may be there. Okay, so different kinds of soil means according to the soil strata, C value will be changing. Okay. So this is the data, and finally you have to determine the safe design load or the allowable load bearing capacity. Safe design load means allowable bearing capacity. Okay. Other things are not much important here to calculate the bearing capacity, but some factor of safety for different conditions are given for which you have to determine the load bearing capacity, allowable load bearing capacity. If this part is not given, this factor of safety and all these things are not given, then that means that is ultimate bearing capacity you have to calculate. And as factor of safety are given for different conditions, that means allowable load bearing capacity or safe load bearing capacity you have to calculate. বুঝতে পেরেছিস? Understand now? So this is the thing, and I have given here adhesion factor also. Adhesion factor means alpha. তোরা সব ভুলে যাচ্ছিস, এই তো কালকে রয়েছে। This alpha, okay, is given, but as your syllabus prescribes that we have to follow the IS code provision. IS code provision. In the IS code provision, alpha can be determined from a plot of unbent shear strength and adhesion factor. Okay, let's
এটা বন্ধ হচ্ছে মুস্কান